Consider the following list. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 16, 5 squared, 25. You get the idea. 6 squared is 36, 7 squared, 49, 8 squared is 64, 9 squared, 81, and 10 squared is 100. All of these are called perfect squares, and when you square root any of them, the answer is going to be an integer. So for instance, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on and so forth. We're going to learn how to simplify square roots, and using the perfect squares will help us. Before we begin with the square roots, I want to go over the parts of a square root. So we begin first with the radical, and the radical is the symbol. This right here that looks like a check mark is called the radical. The number that goes inside the radical is called the radicand. So in this example, it will be the square root of 64. That's how you read it. The radicand is 64, and the symbol is called the radical. We're going to begin with the product property. Now, the product property states that if I have two numbers that I'm going to call A and B, and they are greater than or equal to 0, and we have a square root of A times B, then that is the same thing as having the square root of A times the square root of B. This makes sense that the numbers have to be greater than 0 because we cannot square root a negative number. Now, this property helps us simplify square roots of numbers or expressions that are not perfect squares, such as the square root of 50. I know that 50 is not a perfect square. I know 49 is, but 50 is not. I also know that 25 times 2 is 50, and 25 happens to be a perfect square. So I can rewrite this as 25 times 2. Because of the product property, this is the same thing as having the square root of 25 times the square root of 2. And now the square root of 25 is 5, square root of 2. I'm going to leave the square root of 2 like that because the 2 is not a perfect square, and there are no other factors of 2 that are perfect squares. So we're going to leave it like that. In fact, number 2 is a prime number, so its only factors are, well, actually it's just 1. Its only factor. Let me show you another example. We're going to simplify the square root of 18. Again, 18 is not a perfect square, but I know that 9 is, and 9 times 2 is 18, and 9 is a perfect square. So I can rewrite this as the square root of 9 times the square root of 2. The square root of 9 is 3, square root of 2. That is the simplified expression or the simplified radical. Now we're going to go over another property that is called the quotient property. That one also has a restriction, actually two restrictions. A has to be greater than or equal to 0, and B has to be greater than 0, meaning B cannot be 0. And it is the square root of A over B is the same thing as having the square root of A over the square root of B. Now B cannot be 0 because we cannot divide by 0. That is the reason that we have that restriction. And of course the numbers have to be positive because you cannot square root a negative number. Now let's go ahead and work on an example. Let's say that I have the square root of 100 over 9. If I divide 100 by 9, I will end up with decimals, and that is not going to help me simplify this. So what I can do is that I can use the quotient property and rewrite this square root as a square root of 100 over a square root of 9. Now the square root of 100 is 10, and the square root of 9 is 3. So then that's it. That will be the simplified version. Let me show you another example. Let's say that I have the square root of 64 over 9x squared. Again, because of the quotient property, I can rewrite this as the square root of 64 over the square root of 9x squared. The square root of 64 is 8. The square root of 9 is 3. The square root of x squared is x. So then this will be the simplified version.